Hello, my dear students. In previous class, we have already learned about trigonometric functions and their applications. Today in this class, we will discuss about inverse linear functions. Trigonometric functions are not one and onto functions onto in their natural domains and range. So their inverse do not exist in all values, but their inverse may exist in some interval of their domains and range. So we can say that inverse of trigonometric functions are defined within the restricted domains. They are restricted domains of corresponding trigonometric functions of corresponding trigonometric functions. Trigonometric functions. And inverse of f is denoted by f to the power minus 1. Remember, trigonometric functions are not 1 and onto in their natural domains and range. So their inverse do not exist in the values, but their inverse may exist in the some intervals of their domains and range. So we can say that inverse of trigonometric functions are defined within their restricted domains of the corresponding trigonometric functions, and the inverse of f is denoted by f to the power minus 1. Let y equal to f of x equal to sin x be a functions, then its inverse is sin inverse y. Y equal to f of x equal to sin x be a function, then its inverse is sin inverse y. Similarly, the other trigonometric inverse functions are cos inverse y, tan inverse y, sec inverse y, cosec inverse y, and cot inverse y. The other inverse degree functions are cos inverse y, tan inverse y, sec inverse y, cosec inverse y, cot inverse y. Next, remember sin inverse x is not equal to, remember sin inverse x is not equal to sin x whole to the power minus 1. Number 1, sin inverse x is not equal to sin x whole to the power minus 1. Number 2, sin inverse x is not equal to sin inverse 1 by x. Number 3, sin inverse x is not equal to 1 by sin x. Remember, most important, sin inverse x is not equal to sin x not equal to sin x whole to the power minus 1. Sin inverse x is not equal to sin inverse 1 by x, and sin inverse x is not equal to 1 by sin x. Next, the restricted domains of trigonometric function in which the inverse exists is called principal ones. Now we will discuss principal value of inverse trigonometric functions. Principal value. Now we will discuss about principal value. The value of inverse trigonometric functions, functions which lies in the range of principal ones is called the principal value. The principal value is called the principal value of the inverse trigonometric functions of the inverse trigonometric functions. Okay. What is principal value? The value of inverse trigonometric functions which lies in the range of principal ones is called the principal value of the inverse trigonometric functions. Now let's see. For domain and range of inverse trigonometric functions, table for domain and range of inverse trigonometric functions of inverse trigonometric functions. Table for domain and range of the inverse trigonometric functions. First function, next domain, next range, principal First, sin inverse x, sin inverse x. First, sin inverse x, domain equal to -1 less than equal x less than equal 1, range -π/2, close interval -π/2 to π/2. Next, cos inverse x, cos inverse x is equal cos inverse x, the function cos inverse x domain -1 less than equal x less than equal 1 and range 0, close interval 0 comma pi. Next, tan inverse x minus infinity less than x less than plus infinity and range open interval -π/2 comma π/2. Next, cot inverse x domain minus infinity less than x less than plus infinity open interval 0 comma pi. Next, sec inverse x range domains r minus close interval open interval -1 comma 1 range 0 comma pi minus pi/2. Next, cosec inverse x domain r minus open interval -1 comma 1 minus pi/2 comma pi/2 minus 0. Here, the table for domain and range of inverse trigonometric functions. This is functions and these values are domain and these values are range. The function sin inverse x, the range of the sin inverse x is equal to -1 less than equal x less than equal 1 and range of sin inverse x is equal to close interval -π/2 to π/2. Next, the function cos inverse x, the domain of cos inverse x is equal to -1 less than equal x less than equal 1 and range of the cos inverse x is equal to close interval 0 comma pi. Next, the domain of function tan inverse x is equal to minus infinity less than x less than infinity. The range of the tan inverse x is equal to open interval -π/2 comma pi/2. Next, the domain of cot inverse x is equal to minus infinity less than x less than infinity and range is equal to 0 open interval 0 comma pi. Next, the domain of sec inverse x is equal to r, any real number r minus open interval -1 comma 1 and range is equal to close interval 0 comma pi minus pi/2. Next, the domain of cosec inverse x is equal to r minus open interval -1 comma 1 and range is equal to close interval -π/2 comma pi/2 minus 0. Next, trigonometric ratios of some standard angles. Trigonometric ratios of some standard angles. Theta, sin theta, cos theta, tan theta, cot theta, sec theta, next cosec theta. Zero degree or 0 degree, next 30 degree or pi by 6. Zero degree, 30 degree or pi by 6. Next 45 degree or pi by 4. Next 60 degree or pi by 3. Next 90 degree or pi by 2. Here sin 0 degree equal to 0, sin 30 or pi by 6 equal to 1 by 2, sin 45 equal to 1 by root 2, sin 60 degree equal to root 3 by 2, and sin 90 degree equal to 1. Next cos 0, cos 0 degree equal to 1, cos 30 degree equal to root 3 by 2, cos 45 degree equal to 1 by root 2, and cos 60 degree equal to 1 by 2, cos 90 degree or cos pi by 2 equal to 0. Next tan 0 degree, we know that tan theta equal to sin theta by cos theta. We know that tan theta equal to sin theta by cos theta. Therefore, tan 0 degree equal to sin 0 degree divided by cos 0 degree. Therefore, 0 by 1 equal to 0. Next, sin 30 degree equal to tan 30 degree equal to sin 30 divided by cos 30. Therefore, 1 by 2 divided by root 3 by 2. This equal to 1 by root 3. Next, tan 45 equal to this divided by this equal to 1. Tan 60 degree equal to sin 60 degree divided by cos 60 equal to root 3, and this equal to not defined. Next, cost, we know that cos theta equal to 1 by tan theta. Therefore, cos 0 degree equal to 1 by tan 0 degree. The 1 by 0 is equal to not defined. Next, cot 30 degree equal to 1 by tan 30. Therefore, this equal to root 3, and this equal to 1, and this equal to root 3, and this equal to 0. Next, sec 30. We know that sec theta equal to 1 by cos theta. Therefore, sec 0 degree equal to 1 by cos 0. Therefore, this equal to 1, and this equal to 2 by root 3, and this equal to root 2, and sec 60 degree equal to 2, and this equal to not defined. Next, we know that cosec theta equal to 1 by sin theta. Therefore, this equal to not defined, and this equal to 2, and this equal to root 2, and this equal to 2 by root 3, and this equal to 1. The trigonometric ratios of some standard angles: sin 0 degree equal to 0, sin 30 or pi by 6 equal to 1 by 2, sin 45 degree equal to 1 by root 2, sin 60 equal to root 3 by 2, and sin 90 degree equal to 1, and so on. Now we will discuss some numerical problems from exercise 2.1. Exercise 2.1. Find the principal values. Question number 1. Exercise 2.1. Question number 1. Find the principal value of sin inverse minus 1 by 2. Find the principal value of sin inverse minus 1 by 2. Solutions. Let theta equal to sin inverse minus 1 by 2. Therefore, since theta equal to sin inverse minus 1 by 2, therefore sin theta equal to minus 1 by 2. Since y equal to sin inverse x, therefore sin y equal to x. We know that the range of principal value of sin inverse is minus pi by 2, close interval minus pi by 2 to pi by 2. Already we have learned the range of principal value of sin inverse is close interval minus pi by 2 comma pi by 2. Therefore, we have sin theta equal to minus 1 by 2 equal to implies sin theta equal to minus sin pi by 6. Sin pi by 6, since sin pi by 6 equal to 1 by 2. From the ratio tables, sin pi by 6 equal to 1 by 2. Therefore, 1 by 2 is equal to sin pi by 6. This equal to sin theta equal to sin minus pi by 6. Since already we have learned class 11, sin minus theta equal to minus sin theta. Therefore, this equal to this. Therefore, theta equal to minus pi by 6, which is belongs to closed interval minus pi by 2 to pi by 2. Therefore, the principal value of sin inverse 1 by 2 is equal to minus pi by 6. Therefore, the principal value of sin inverse minus 1 by 2 is equal to minus pi by 6. Okay. Next, we will discuss question number 5. Cos inverse minus 1 by 2. Find the principal value of cos inverse minus 1 by 2. Solutions. Let theta equal to cos inverse minus 1 by 2. Therefore, we have cos theta equal to minus 1 by 2. Since sin x equal to y, then x equal to sin inverse 1. We know that the range of principal value, the range of the principal value of cos inverse is 0 close interval 0 comma pi. The range of principal value of cos inverse is close interval 0 comma pi. Therefore, cos theta equal to minus 1 by 2. This equal to cos theta equal to minus cos pi by 3. Since cos pi by 3 equal to 1 by 2. This equal to cos theta equal to cos pi minus pi by 3, because cos pi minus theta equal to minus cos theta, because cos pi minus theta equal to minus cos theta. Therefore, minus cos pi by 3 is equal to, we can write cos pi minus pi by 3. Cos theta equal to cos 3 2 pi by 3, 2 pi by 3. Therefore, theta equal to 2 pi by 3, which is belongs to close interval 0 comma pi, which is belongs to 0 comma close interval 0 comma pi. Therefore, the principal value of cos inverse minus 1 by 2 is equal to 2 pi by 3. Next, we will discuss question number 10. Question number 10. Find the principal value of cosec inverse minus root 2. Find the principal value of cosec inverse minus root 2. Solutions. Let theta equal to cosec inverse minus root 2. Therefore, cosec theta is equal to minus root 2, since cos inverse x equal to y, then x equal to cos y. We know that the range of principal value of cosec inverse is close interval minus pi by 2 comma pi by 2, close interval minus pi by 2 comma pi by 2 minus 0. Close interval minus pi by 2 comma pi by 2 minus 0. Therefore, cosec theta equal to minus root 2. This equal to cosec theta is equal to minus cosec pi by 4, since cosec pi by 4 equal to root 2. This equal to cosec theta is equal to cosec minus pi by 4, since cosec minus theta equal to minus cosec theta. Cosec minus theta equal to minus cosec theta. Therefore, theta equal to minus pi by 4. Therefore, the principal value of cosec inverse minus root 2 is equal to minus pi by 4.